Hi, today in this video I will be explaining the topic region of convergence of right-sided signal. First we will see what is the definition of ROC. ROC means a range of complex variables S in the S plane for which the Laplace transform is finite or convergent, or in simple words we can say the values of S for which the integral remains constant. Now in the Laplace transform definition, we have seen that uh, the complex variable S is equal to sigma plus j omega, where sigma is the Napier frequency and omega it is the radian frequency. Now we will find the ROC of the right-sided signal. Well, let us consider a causal signal, uh, like consider a causal signal like x of t is equal to e raised to at u of t, t is greater than or equal to 0. Since we know that every causal signal is a right-sided signal, now what will be the Laplace transform equation of this? Yeah, the Laplace transform x of t will be equal to x of s, that is integration minus infinity to infinity x of t into e raised to st dt. Now that since it is t greater than or equal to 0, the limits here it will change 0 to infinity. X of t integration 0 to infinity e raised to at into e raised to minus st dt. Now further integrating, simplifying the equation, we write integration 0 to infinity e raised to minus s plus a into t dt. Now here we'll have simple integration. The integration will be e raised to minus s plus a t upon minus s plus a, limit is 0 to infinity. Here the value, here we have this simple integration. After this step, there is it is important, for if the question is asked to find the Laplace transform, then we have to simply put the values of the limit. We have to simply put the values of limit 0 and infinity and solve further. We will get the answer. That will be the Laplace transform. But if it is asked to find the ROC of the equation, we have to take the values of s plus a. We have to take the value of s, that is s is equal to sigma plus j omega. We will have to substitute the value of s in the numerator only, that is the step to find the ROC. Now we will substitute the value of s in ROC. We will see here x of s, will take the denominator outside, that is 1 upon minus s plus a. In this we have substituted the value of s, that is sigma plus j omega plus a into t, limits 0 to infinity. Now this here we have the real and imaginary part. So next step is to separate out the real and imaginary part. So it will become e raised to minus sigma plus a into t into e raised to minus j omega t, limits 0 to infinity. Now from here we will put the limits, we'll apply the limits. So that will become 1 upon s plus a e raised to sigma plus a infinity into e raised to minus j omega infinity minus e raised to 0 into e raised to 0. So here it will become 1. So now after this, if we solve the equation, we will have two conditions. That is e raised to minus infinity, or that is e raised to minus infinity or e raised to infinity. We know that the Laplace transform is convergent when it is present in the region of convergence. So for this to happen, the condition is the integration should give some finite value. So it should give some so this integration should give some finite value. So for this the condition is that we should get some finite value. So e raised to infinity is infinity, so this is not a finite value, but e raised to minus infinity is 0, so it is finite. So how to find this 0? So for that, the sigma plus a, it should give some finite value, so we will get e raised to minus infinity. So for that, the condition is sigma plus a is greater than 0. Sigma plus a is greater than 0 means sigma is greater than minus a, that is sigma c is equal to minus a. This is the abscissa of convergence. This is abscissa of convergence. Now we will take this sigma plus a total as e raised to minus infinity. That it will become 1 upon minus s plus a e raised to minus infinity into e raised to minus infinity minus 1. So the result is 1 upon s plus a, e raised to minus infinity will become 0 minus 1. Further solving, we will get 1 upon s plus a. So that is so the answer is x of s is equal to 1 upon s plus a. So this is the Laplace transform. The Laplace transform is 1 upon s plus a. Now we have to find the region of convergence. The region of convergence, for that, and we have sigma c is equal to minus a. Sigma c, that is um, the abscissa. This implies that the values, this equation sigma c is equal to minus a, this implies that the values to the right side of this abscissa, the values to the right side of this abscissa are convergent or integral remains constant. So for that, we will draw an axis. So this is the s plane. So in this s plane, we have the right side. On the right side we have here a, and on the left side here we have minus a. So on this point is called as the abscissa of convergence. This point is called as the abscissa of convergence, and the remaining part from this point to the right side of this point, all the part which is to the right of this point, this right of this point, this is the ROC of the equation. So this is the ROC of right-sided signal. Right-sided signal, or we can say on this part, or we can say that on this part the Laplace transform is convergent, or the integration will give finite value. Thank you very much.